Okay, boy, are we excited to be here once again. We're with the undisputed hydro weight champion of the world, Harley Smith. I'm the organic mechanic with Kelp4less. And on the side of the screen, we have some test data that we wanted to throw up and go over. And what's neat about this test data is I'm really excited about it. This was a larger scale test on soil, agricultural soil, that consisted of about 11 farms spread out amongst 800 acres. And it's all irrigated. And what's unique about these tests is it's all drip irrigated or micro sprinkler irrigated. So there's no overhead water. It's all precise irrigation, which can really help in moisture management in agricultural fields. But what I'm so excited about is each of these fields ran our living water system. And if you don't know about our living water system, you can go to wesavesoil.com and look all about it, read all about it, and see what's going on. But this was a 6-month test. So we did a biological soil test before we started. And we use a company that's called Earth Fort Biolabs. And they set a very high standard for this testing. So we've used them quite often. And so I'm really confident in the results that they give me back. That kind of lets me gauge where we're at. So anyway, back to these tests, is about 6-month time period of living water on all of these fields, where with living water, we infuse beneficial bacteria, beneficial fungi, actinomycetes, some pseudomonads, and biostimulants at every irrigation. So this is a large scale test. So anyway, if you can see on the screen, I want to go over some of these things that we found out. On line number 3 of this graph, it says 37 acre shop. This is one of the smaller fields that we did. And as you go across the board on that, you can see the bacteria levels increased 29%, and these are the beneficials. Fungi increased 195%. Fungi to bacteria ratio 128%. Now here's the good ones. Biological carbon increased 107%. Biological nitrogen increased 50%. Carbon to nitrogen ratio up 38%. Okay, so this is just a small field, you know, not a large scale, but it's very significant to see these kinds of gains in the biological spectrum of the soil, because it equates to you can really dial in your inputs for next season. You can really make adjustments for the biology that's in the soil. For instance, with a 195% increase in fungi, we know that phosphorus is going to be able to move into the plant from the soil. So when we do the traditional soil test, it may call for 150 to 200 pounds of phosphorus for the crop. We'll know now with our fungi levels so high, we can really use a much smaller amount of phosphorus. I would say we could probably take that phosphorus recommendation and split it in half. So let's say if they recommended 200, maybe let's look at starting out with 100, just to make sure the phosphorus is there, because plants need nutrients, but we know it's going to become available unless there's a catastrophe. And these fields, we know the fungi will be there next year too, because there's no tillage in these fields. There's no tillage. There's going to be roots for the fungi to live on. It will get cold, but we know that base will still be there in the upcoming crop year. So, and just taking a look at these numbers, there's 11 fields here, and we go down the 11 fields, and basically all of them are showing fantastic results across the board. Fantastic results. And I know Harley and myself, we were reviewing this off camera, and Harley brought up some really good points too on just the substantial increases in the carbon to nitrogen ratio. And maybe you could take a minute and address some of those things you were telling me on that, Harley.
Okay. Well, carbon to nitrogen ratio isn't something in hydroponics that we really look at
Hmm.
because we're not dependent on microbiology to make nutrients available. But of course, whenever you get into composting and you're talking about healthy soil, you know, then microorganisms need carbon for their
Hmm.
metabolism and they need nitrogen. So
Hmm.
if you have a, the right carbon to nitrogen ratio, then that's a sign that that the microbes are going to be able to thrive, that they'll have a vigorous community of enthusiastic community of plant growth promoting rhizobacteria and fungi, that the soil is able to support that community. So seeing increases in that, I'm guessing that because I'm not that familiar with this soil analysis, but I'm guessing that that's an example of a healthy and improving soil,
The ecosystem, the
the whole
the
ecosystem.
ecosystem. Yeah, it's getting more developed. It's getting more structured. It's like a new neighborhood that comes into town. When they start any type of construction, or I mean, first you got to do the land work, then you put in the roads, then the sidewalks and all the facilities. We're doing that in the soil. That's what's happening. We're creating a community where living organisms can thrive and plants can thrive in it, and it just makes everything easier. And so it's very exciting. And on this little sheet, if you come down here to the block 2, the block 2, a 660% increase in beneficial fungi, a biological carbon, a 184% increase, bioavailable nitrogen, 77% increase. Let's talk about this number, the biological nitrogen.
Right.
So we started on this particular field. It was at 70. You know, Anyway, after 6 months of our living water program, it almost doubled. Not quite, but almost doubled. I mean, it went to 120, 24.
Yeah.
So that's a 77% increase. And what this means on a farm, what this means to the grower, the customer, the soil, is we know nitrogen is going to be available. And typically in these drip irrigation, um, well managed farms, we supplement all season long with nitrogen. Okay,
Mm.
we spoon feed it like we do in hydroponics. We don't want to overdo it.
Right.
So in this case, it is going to be so much more easy. It's going to be just so easy to manage our nitrogen inputs because we're expecting, a lot of this biological nitrogen to help supplement the plant through the growing season. So once again, this is really going to eliminate a lot of cost and a lot of time to the customer because we know what we're going into. So we can really plan ahead on uh, our fertilizer program, our nutrient regimen, whatever you want to call that, knowing that we've prepped the soil for next year. And and what's great about this is we haven't even harvested the crops yet.
Right.
So, but they look great, and we're very excited because this is going to follow through on the yield. It's going to follow through on the quality, and it's going to follow through on the nutrient density. It has to. I mean, we set up the system, the plants are responding to it, the soil's responding to it, and it's going to be knocked out of the park. We're really, really excited. And like I said, I was just like a kid. I couldn't sleep when I got all these tests back at the night and going over them. And it's just very exciting because we really are doing huge changes in the soil rapidly. This is just one growing season. And,
Mhm.
and I brought this up again. If you asked anybody, how much would you pay to increase the mycorrhizal fungi in your soil? How much would you pay to get such a large increase that you could cut your phosphorus needs of a plant by half? People would pay a lot of money for that because it's so valuable. And to
Mhm.
know we did it on a very inexpensive platform of $5 per acre, where we constantly inject the beneficials at every irrigation. It's a home run. It's kind of game over. We're getting this figured out. Super excited.
Yeah, that's exciting because we know all of us know the benefits of compost, right? But then you add it to the soil, and then it's just whatever happens during the growing season. You can't keep adding it. You can't spoon feed compost, right?
Exactly.
To keep
Exactly.
the microbes active and keep the soil healthy. Well, here we're doing it. We're adding a whole new level of control in the environment where we couldn't do that before. And by adding the biostimulants each time, adding the microbes each time, there it's going to have a cascade of positive side effects. And one thing I'm
Exactly.
noticing here with the biological nitrogen, maybe you can explain that to me a little more, but uh, I know that when I was working with some of the aquaponics people, we're growing the fish and the hydroponics in the same system. You know about
Hmm.
aquaponics, that you're feeding the fish, and then the waste material from the fish feed the plant, and then the plant cleans the water for the fish. But in
Yes.
between, there's a biological filter with microbes. And there was always a challenge in aquaponics to have that ammonium to nitrate ratio stable, because the ammonium could get out of control, could get too high or get too low. Anyway, one of the top aquaponics growers in the country did some trials with amino acids. And he
Hmm.
said after doing the trials that was the most stable form of nitrogen, because it's a slow release and being processed by the microbes, the most stable out of any nitrogen source he's ever used. So I'm just this is just insight. I don't know that much about biological nitrogen here in the soil, but can you comment on that a little bit about what form of nitrogen that is, or do you even know
Yeah.
what the ammonium to nitrate or the amino acids, what that refers to?
Yeah, you bet. You bet. And I just want to go back to one of your first points. So, talking about compost. So, we're setting the soil up to compost the organic matter naturally. I mean,
Right.
how it's supposed to happen in the soil. That's where we want, all these, things to go on is in the soil rather than having to haul it in. If we can get enough organic
Yeah.
matter down there that's converting, we're making compost in the soil. And that equates to the biological nitrogen number that they have here. So what that is, the biological nitrogen is just a formula that bases the organic matter and the amount of the nitrogen fixing microbes that are down there. And so what that is, that tells you the potential. The potential is there, the increased potential, and any increase we can get, we know we can, healthier soils and more profitable operations for the farmers. And so what that is, it's a percentage of increase in what's going to be available biologically. So whether tied up in organic matter through nitrogen fixation, it's the potential.
Yeah.
Very, very important. Very, very
Yeah, that
important.
is very important. That's one of the benefits of really good microbiology in the soil anyway, is because the microbes sequester some of the nitrogen as they're processing
Absolutely.
it. They sequester it so it doesn't just get washed away. It's held there in the root zone, and then as the bacteria eventually die, or really very rarely do bacteria die of old age. You know, they're eaten by other microorganisms in the soil, as you were talking about, the ecosystem, and then they're released back in plant available form. They're released back in the soil. So it's really holding on to nitrogen, and then kind of naturally spoon feeding it during the growing season.
Absolutely. Absolutely. It's exactly the form of nutrient you want. It's sequestered in the soil. It's not going to leach. It's not going to evaporate. It's going to be available when the plant needs it. It gets no better. You have it right where you want. And it just makes growing plants when you're outside of a controlled environment a lot easier. You know, the health of the plant, if you can set this up to, uh, again, I always go back, setting yourself up for success. That's what we're trying to do here. And another really neat number that stands out on these earth fort biological tests is they measure EC in the soil. And as a lot of our viewers know, a lot of us look at the EC in hydroponics to kind of gauge what our nutrient level is, and
Yeah.
and so on and so forth. But in an agricultural soil, it doesn't work that way, because EC basically is a measurement of salt, the
Mhm.
electrical conductivity, and it's basically the measurement of. Anyway, we don't need to go into that right now. But what's neat about these tests is our EC is going down dramatically in a lot of these fields. And I know what's going on there, because when we measure EC in soil, it's a measurement of salt to me. They're salty soils, and this farm has salty water. And the more biological diverse we can get in the root zone and in the soil, we know that the plant's going to make an environment that is going to bring that salinity down. The microbes do that. The fungi does that. The organic matter decomposition does that. So if we can continue to bring the salts down in the soil, even while we're watering with salty water, we're on a great path for success. If we can keep influencing the soil this way with doing the living water and stay on this trajectory moving forward, we're going to see some really, really neat things, more than a soil test. We're going to see really neat things with food nutrition and the crops and the health of everything surrounded with it. Very, very excited. Fantastic.
Yeah. Uh, Maybe you can help me understand this, because I'm just looking at, for example, at bulk 3, bulk 3 on
Okay.
EC, and it looks to me like it started. Oh, I see. Never mind. The top line is where it ended. The
Yes.
second line is where it started. Okay.
Yes.
I think I
Yeah.
answered my own question. I was saying, how can one start at 127 and end up at 409 be a decrease? It's just because I wasn't looking at the dates. So never mind.
Exactly.
It's not before
Exactly.
and after, top to bottom, it's bottom to top.
And do you know what, Harley? What's really neat about this is the increased fungal levels, because
Hmm.
with our living water system, I have had so many discussions with, I mean, PhDs, university professors, and just on and on. And every one of them have told me the way we're doing this, you're not going to be able to propagate the fungal the way you're doing it with living water. Everyone have told me it's not possible. And I'm not
Mm-hmm.
saying they're wrong. All I'm saying is, well, it's happening. This is
Right.
this is really happening, and it shows on the testing. And so, um, what we're doing here is so unique and so affordable. It's almost hard to believe. What what if we can get these? What if we can get 1,000% increases in one growing season?
Mm.
Now we're talking. Well, we're halfway there. We can fine tune some of the microbes and fine tune some of the biostimulants and just keep pushing this further if we can. We're off to a good start. So it can be done. It is doing done. The proof's in the pudding, and I can't
Mm-hmm.
wait to eat some of these crops.
Yeah. And it's what's really cool. This is just one growing season.
Yes.
This is your first summer, spring, summer, fall. And
Yes.
with no-till, a lot of that fungi is going to survive. A lot of it will survive over the winter because you're not tilling up the soil and breaking into pieces. So you have a
Exactly.
better base to begin with. Now, you may not see as much increase, or, but who knows? Maybe we will. Maybe it's going to go up and up. Like you said, maybe instead of 600% increase, um, it'll be 1,000. And that just means that the phosphorus will be more available. And when you unlock the phosphorus, the calcium becomes more available. The iron becomes more available. Some of those limiting factors. So yeah, this is significant, and I can hardly wait for another growing season to see where we go from here.
Yeah, yeah, we're starting some trials in uh, southern Arizona, in the Yuma area, and in southern California as well. So we can do some winter projects down there. And with what we've seen across the board, as far as a soil health overview, we're really doing good things. We are really doing good things. And so, like you said, we're just getting started. We'll
Yeah,
keep moving forward. And boy, I sure appreciate you and all the discussions we get to have and all the questions I get to ask you and all the you're a great mentor on a lot of things I don't have answers for. So I appreciate the time you spend with me. We'll uh, we're I'm going to change the world. Let's do it.
I think you just got pumped up in your enthusiasm level. It's great to go from uninformed optimism to informed optimism. I mean, the numbers.
That's a good way to put it.
You know, I'm a scientist, as you know, and I look at I look at the data. Um, I had a talk this week with someone who wants me to do some development of a new product and fertilizer and stuff. He said, "Well, how many times should you do a leafing test?" I said, "Well, you only need a few if you want a few key points to measure." I said, "But you can't have too much data, and we'll improve that over the years, and then we'll be able to explain it." And right now we're seeing it. Remember the university guys, they're scientists, and they said, no, you're not going to be able to increase the fungi, you know? But we
Yeah.
did.
With
Now, the
with the
question
method we're
is,
doing it. Yeah, with the
the method
method we're
you're
doing, it's
using
not going to.
did it. Now, the question I have is why? And the why is something that we have time to think about and time to then study a little bit more and then unlock some of the mysteries of nature. And if we have that, to me, that's my payoff. If I can unlock one mystery of nature that's been hidden for all these years, I feel like, I start feeling like you. My hair starts standing up and I can't sleep. So yeah, we're at the beginning of maybe another round of making the world a better place, improving, uh, reducing our fertilizer inputs,
Yes.
reducing the need for pesticides and fungicides, improving quality and yield and nutritional value, help the farmers to make a good living, and protect the consumers and
Yeah.
provide a healthier food supply for the future.
Absolutely. Yeah, we're right in line there. Now, this next set of data I'm going to have for you are these same fields with the leaves with the sap analysis,
Mm,
the monthly sap analysis. So, and let me tell you, they have been very good, well performing all season long. So we have the soil biological assays, and then we're going to coincide that with the plant sap analysis. And and both are going like this. And so I'll get that data compiled and shoot it over for you, and we can answer some of those questions of, okay, this looks good, but what is it doing? I mean,
yeah,
how do you prove this is helping the plant? Well, we have the SAP analysis too. So very good data.
yeah. And I think we need to wrap up, but I'm going to throw one little prediction out there
Okay.
so you can maybe prove me wrong. The data is what I do. That's what I think and what it is. A lot of times two different things. But when the EC is going down, even in hydroponics, when the EC goes down, that tells me that the plant is taking out more. It's taking it out of the soil solution, the minerals of the soil
Mm-hmm.
solution, so it's becoming more dilute because more is in the plant. There's only two places it can go. It can either be leached away, held locked up in the growing medium, or taken up by the plant. So I don't know. We'll see. And it's
Yeah,
maybe not a one to
you're
one
right.
ratio, but I'd be very curious to see what the soil analysis says, especially on phosphorus. We'll
Yeah,
see.
this is going to be great. And we'll get the mineral assays too.
Okay. Well, that's good for today. Thank you so much for this, sharing this, the first glimpse into the
Yeah.
data, sharing it with the world. So I feel privileged to be able to have this podcast with you today.
All right, this is fun. I can't wait for the next one.
Okay. All right.
Okay.
For through, I guess I'll see you next week.
Okay. Happy Thanksgiving.
Same to you. Bye bye.
Bye bye.